Okay, so the next thing we're going to talk about is linear relationships. It relates to what you've been doing in Math Plus with slope, and you've started talking about the intercepts, and now it's going to carry over, and we're going to do some more practice with our math class. When we're talking about linear relationships, we're talking about lines. And all of our lines can be graphed on our coordinate grid. So quickly, I'm going to review just the coordinate grid. This horizontal line is your x-axis. So when you're graphing a point and you're graphing the x value, you're looking at the tick marks on the x-axis. Anything to the right of the origin is positive. Anything to the left of the origin is negative. My vertical line is my y-axis, and it's the same thing. Anything above the origin is positive. Anything below the origin is negative. So when I'm graphing a point, I need to look at the x-axis first and then the y-axis. So if I have the point 1, 4, and I want to graph this point, I know all of my points are written as x, y. So I graph 1 on the x-axis, and then I go up 4 on the y-axis. So this is the only point on the entire grid that can be positive 1, positive 4. So we're going to start talking about points that together make lines. Here I have a table that I'm going to graph each of the points on the table, and I'm going to see what happens. So if I have, this is not the table I want, so let me write down my values. So if my table, my x values are -3, -1, 0, 1, 3. My y values are -5, -1, 1, 3, and 7. So I'm just going to graph these 5 points. If I have -3, -5, I have to go to the left 3, and then down 5. 1, 2, 3, 4, 5. So it's not perfect, but it's going to be about here. -1, -1, I go to the left 1 and down 1. 0, 1 is going to be right here. 1, 3 is x of 1, and then 3 on the y. And then my last point is 3, 7. I go to the right 3, and then up 7. 3, 4, 5. So it's going to be about here. Now I'm doing that freehand, so it's not going to be perfect, but it's going to roughly make a line that looks like this. And now this line is going to go on and on forever and ever, but we're just looking at these values right here. So now I need to figure out how to write the equation of this line. When I'm writing the equation of any line that is just a straight line, there has no curves if you do it correctly, and everything falls, all the points fall on the line, I need to be able to figure out the equation of this line. You've seen y equals mx plus b in Mrs. McCoy's room. So very quickly, we're just going to review that in the y equals mx plus b, your x represents all of the x values on this line. Your y represents all of the y values on this line. So your x and y can always change because you can be talking about this x and y, you can be talking about this x and y, there's x and y's in the middle. But the slope and the y-intercept are always going to be the same when I'm talking about this line. This line, the slope is not going to change at any point in the line, even if you go all the way down here. And it's always going to have the same y-intercept because it can only cross the y-axis in one place. So my m is my slope. My b is my y-intercept. When I'm trying to figure out the y-intercept, if I'm looking at a graph like this, it's really easy to figure out because I'm just looking to see physically where the line crosses the y-axis. And I can see, even though it got a little erased, that it crosses right here. And that's at the point 0, 1. It was a point on my line, and it's also the y-intercept. So I'm going to write that, when I write this equation, as a positive 1. So plus b becomes plus 1. Because this y-intercept is at positive 1, my b is plus 1. If it was -1, it would be -1. If it crossed up here, it would be +8, etc. So I know that my y-intercept is +1. Now I also need to find the slope to write the equation of this line. So my slope, you've learned how to find, is the rise over run. So I can do my slope triangle here. I can use my table here. They're both ways of finding the slope of this line. If you want to do it here, I find this to be the easiest when you're dealing with nice clean points like this. My rise is 2, my run is 1. Well, if slope is rise over run, I get 2 over 1, so my slope is 2. So my m becomes 2. And like I said earlier, your y is going to change, your x is going to change. So if someone were to say to you, what is the equation of this line? The answer would be y equals 2x plus 1. Because my slope I plugged in, and my y-intercept I plugged in. Let's try this with a different table. Let's see if I can erase this without erasing all of my pretty coordinate grid. Fix that. Okay. It's not too bad. My next table is going to be, I just did a few less points because now that you see what's happening, I have -2, 0, and 2. I have 4, 0, and 4. So I'm going to graph the point -2, 4. -2 means I go to the left because I'm going to the negative side. +4 means I go up 4. So that point is roughly here. 0, 0 is an easy one. That's right on the origin. And then my last point is +2, should be -4. +2, down 4. 1, 2, 3, 4. Again, it's not perfect because I'm trying to do this freehand. So my line looks roughly something like this. We'll keep going up forever and ever in that direction and down forever and ever in that direction. So I need to figure out the equation of this line. I know it's going to be y equals mx plus b. My y and my x are going to change because every point on this line can work. My m, let's see, I'm going to rewrite this where we can sub in the values as we find them. So when we find the m, we'll sub it in, and when we find the b, we'll sub it in. Okay, I think it's always easy to start with your y-intercept when you're looking at the graph because you can just see where it crosses. I see that this crosses at the origin, so it's going to be +0. So I can take out my b, and I can sub in +0. And now I just need to find my slope. I can use my table. Here I'm going down 4, down 4. Here I'm going up 2, up 2. So my change in y over my change in x, -4 over 2 equals -2. If you don't like doing it from a table and you prefer to see it visually, you can use the rise over run from 2 points. So my rise, it's going downhill, so it's going to be -1, 2, 3, 4. And it's going over 2. So +2 down 4 still gets -4 over 2. So when I'm doing this here, I'm doing these, it's the same thing, it's just 2 different ways of seeing it. And this simplifies to -2.
Please excuse the interruption, but will Omie Odaya please report to the main office? And the following
So
students,
I sub in my
Kristen
m
Lincoln,
as -2.
Talia Top, Michael Tierney, Stephen Travis, and Sarah Tripp. You must see Mrs. Savoy today in room F 306 in order to order your cap and gown for graduation.
Okay, I'm not starting this video over because this is my third attempt. So, we've learned how to find the equation of a line from a table and from a graph. Now, if you don't want to graph it at all, and you want to just use the table to find the equation, you can do that. We figured out that m, from finding the rise over run, is -2. And right here, I can see that it crosses through the origin, so my y-axis has to be 0. Now, when I have an equation like this that has a plus 0, I can write it as y equals -2x. So the equation of this line is y equals -2x, or y equals -2x plus 0. This equation cannot describe any other line on the coordinate grid. This is almost like the name of this line. The other line we drew earlier, that equation could only create that line. For example, if I wanted to go backwards and I have the equation and I want to see what the line would look like, so say I have, we're going to start with an equation. Y equals 1/2 x minus 1. So I can do this in one of two ways. I can start at my y-intercept. My y-intercept is where I cross the y-axis. So this line is going to cross the y-axis at -1. So this here has to be a point on this line. My slope is 1/2. So that means I'm going to rise 1 and run 2. So I go up 1/2. Here's my next point. Up 1/2. Here's my next point. I can go backwards and go down 1/2. And this point's also on that line. And then, so this equation can only ever represent this line, even if it's all the way down here or all the way up there. I hope that makes sense. I know that was a lot of information. We're obviously going to do a lot more practice with this. And let us know if you have any questions.